In this video, we're learning how to solve absolute value equations, and at the top of our screen it says, to solve absolute value equations, first isolate the absolute value, then set what's inside the absolute value equal to the positive and negative value of the other side of the equation. So before we take a look at example 1, we just want to remember that absolute values turn every number positive except for 0. So the absolute value of negative 8 is 8, the absolute value of positive 8 is also 8. The absolute value of 0 is just 0, but for every other number, the absolute value turns it positive. So let's look at example 1, which says the absolute value of 4p is equal to 24. So our tip at the top says we want to isolate the absolute value. In this case, the absolute value is by itself. There's nothing else on the left side of our equation. So now what we want to do is set the inside of the absolute value, so this 4p, we want to set it equal to the positive and negative value of the other side of the equation. So we're going to set it equal to a positive 24, and we're going to do another equation. 4p is equal to negative 24. So when we're solving absolute value equations, almost all of the times we're going to have two equations. The only time we won't is if the right side is equal to 0. So now let's just talk about why we're doing this. So because absolute value turns everything positive, that means that whatever's inside my absolute value, so this 4p, could equal positive 24, and when I take the absolute value, that'll come out to positive 24. It could also equal negative 24, and when I take the absolute value of negative 24, it'll become positive 24. So now let's solve each of our two equations. So on the left, we have 4p equals 24. To get rid of the 4 that's being multiplied, we're going to divide both sides by 4. The 4 divided by 4 on the left turns to 1, so we're left with 1p, which is just p. On the right, 24 divided by 4 is 6. So we get that p is equal to 6. For our right equation, we're going to do the same thing. Divide both sides of our equation by 4. 4 divided by 4 is 1, so we're left with 1p on the left. On the right, negative 24 divided by 4 is negative 6. So we get that p can equal 6, or p can equal negative 6. So we have two answers for this example. So let's take a look at a more challenging example. So number 2 says 12 minus 2x is equal to 8. So again, our absolute value is isolated. We don't have anything else on the left side of the equation except for this absolute value. So we're just going to go straight into making our two equations. So we're going to take what's inside the absolute value, and we're going to set it equal to the positive version of the right side of the equation. So we're going to have 12 minus 2x equals 8, and then we're going to take what's inside the absolute value and set it equal to the negative version of the right side of our equation. So we're going to set it equal to negative 8, and now we're just going to solve each equation separately. So let's solve the left equation first. We have to get rid of the 12 that's being added, so we're going to subtract 12 from both sides of our equation. 12 minus 12 is 0, so we're left with negative 2x. On the right, 8 minus 12 is negative 4. And now we need to get rid of the negative 2x that's being multiplied, so we're going to divide both sides of our equation by negative 2. Negative 2 divided by negative 2 is 1, so we're left with 1x on the left, which is just x. On the right, negative 4 divided by negative 2 is a positive 2, so we get that x can equal 2. And now we're going to solve our right equation. So again, we want to start by subtracting 12 from both sides. 12 minus 12 is 0, so we're left with a negative 2x on the left. And this time, negative 8 minus 12 is going to give us a negative 20 on the right side. And now, again, to get rid of the negative 2 that's being multiplied, we're going to divide both sides by negative 2. We are left with a 1x, or an x, on the left. On the right, negative 20 divided by negative 2 is going to give us a positive 10. So we get that x equals 2 or x equals 10 as our two solutions. Let's take a look at some more examples that are a little bit more challenging. So example 3 says the absolute value of 3x plus 16 is equal to negative 40. So for this question, we want to think about what the absolute value does. So absolute value turns everything except for 0 positive. which means we can never get a negative value from the absolute value. So it doesn't matter what we put in for x. The absolute value of 3x plus 16 can never equal negative 40 because absolute value will never be negative. So for this problem, if you ever have the absolute value of something is equal to a negative number, you're going to get no solution. So it's pretty easy because we didn't have to solve anything, but just remember, if you ever have that the absolute value of something is equal to a negative number, your answer is going to be no solution. So now let's take a look at example 4, which also has a negative on the right side of the equation. So just because you have a negative on the right side of the equation does not mean that your answer is no solution. Remember that we have to isolate our absolute value first. So before we can evaluate if we have a solution or not, we have to get this absolute value by itself. So the way we're going to do that is first by getting rid of this negative 24 on the left side of our equation. So we're going to add 24 to both sides of our equation. And now we have the absolute value of n plus 15 on the left. And on the right, negative 8 plus 24 is going to give us a positive 16. So now that we have the absolute value by ourselves, the other side of our equation is positive, so we are going to have a solution. So now we want to go into breaking up our equation into two equations. So we're going to take what's inside the absolute value, n plus 15, set it equal to the positive value of the right side, and we're going to take what's inside n plus 15, set it equal to the negative value of the right side, so negative 16. And now we're going to solve each equation separately. So if we solve the left equation, we're going to subtract 15 from both sides. 15 minus 15 is 0, so we're left with n. And on the right, 16 minus 15 is 1. So we get that n is equal to 1. And for our right equation, we are also going to subtract 15 from both sides. On the left, 15 minus 15 is 0, so we're left with n. And on the right, negative 16 minus 15 is negative 31. So we get that n is equal to 1, or n is equal to negative 31. Let's take a look at some more examples. So example 5, we have the absolute value of 4k plus 1 minus 3 is equal to 22. So remember, what we need to do first is get the absolute value by itself. So we can do that by adding 3 to both sides of our equation. On the left, we're going to be left with 4k plus 1 in absolute value. The minus 3 and the plus 3 go to 0, so they cancel each other out. And on the right, 22 plus 3 is 25. And now that we have the absolute value by itself, we can make our two equations. So we take the inside of the absolute value, 4k plus 1, set it equal to positive 25. And we take the inside of the absolute value, 4k plus 1, we set it equal to negative 25. I'm going to solve the left equation first. Remember to use reverse PEMDAS, so I want to get rid of this plus 1 before I get rid of the 4 that's being multiplied. I'm going to subtract 1 from both sides of our equation. I'm left with a 4k on the left. On the right, 25 minus 1 is 24. Now I need to get rid of the 4 that's being multiplied by dividing both sides of my equation by 4. On the left, I am left with a k, and on the right, 24 divided by 4 is 6. So I get one answer as k equals 6, and now I'm going to solve the right equation. Again, I want to start by subtracting 1 from both sides. I'm left with a 4k on the left. On the right, negative 25 minus 1 is negative 26. I want to divide both sides by 4. So I get k is equal to negative 26 over 4. And I just want to simplify this by dividing the top and bottom by 2. I'm going to get negative 13 over 2. So I get k equals 6, or k equals negative 13 over 2 as my two answers. So now we're going to take a look at example 6, which is going to get a little bit more challenging. So we have 10 minus 2 times the absolute value of 2a plus 6 is equal to negative 18. Again, we want to start by isolating our absolute value. Using reverse PEMDAS, we know that we want to get rid of this 10 that's being added before we get rid of the negative 2 that's being multiplied. So we're going to get rid of the 10 by subtracting 10 from both sides of our equation. On the left side, 10 minus 10 is 0, so we're left with negative 2 times the absolute value of 2a plus 6. And negative 18 minus 10 is negative 28. And now this is very important. You cannot distribute numbers into absolute values. So we're not going to distribute this negative 2 in. We want to get the absolute value completely by itself by dividing both sides of our equation by negative 2. So just to reiterate, do not distribute numbers inside of our absolute value. Negative 2 divided by negative 2 is 1, so we're left with the absolute value of 2a plus 6 on the left. On the right, negative 28 divided by negative 2 is positive 14. So we have our absolute value isolated. We have a positive number on the other side. So we're going to break up our absolute value into our two equations. So we're going to have 2a plus 6 equals positive 14. And 2a plus 6 equals negative 14. For the left equation, we want to start by getting rid of the plus 6. So we're going to subtract 6 from both sides. We're left with 2a on the left, 14 minus 6 is 8 on the right, and finally divide both sides by 2. We get a is equal to 4 as one of our answers. And now for our second equation, we also want to start by subtracting 6 from both sides. We are left with a 2a on the left. On the right, negative 14 minus 6 is negative 20. Divide both sides of our equation by 2. We're left with a on the left and negative 10 on the right. So we get that a is equal to 4, or a is equal to negative 10. Let's take a look at two more examples. For these final two examples, I encourage you guys to pause the video and try them on your own, and then you can watch my explanations when you're finished to make sure that you get the correct answer. So example 7, we have the absolute value of 2b minus 3 all divided by 5 plus 6 equals 13. So we need to get the absolute value by itself before we make our two equations. So we want to start by getting rid of this positive 6 on the left side of the equation. So we need to subtract 6 from both sides. So now we're left with the absolute value of 2b minus 3 all over 5 is equal to 7. And now we want to get rid of this 5 that is being divided. So we have to do the inverse, which is multiplication. And the 5's cancel out and turn to 1, so we're left with 2b minus 3 in our absolute value. And on the right, 7 times 5 is 35. And now we can make our two equations. So we're going to set what's inside equal to positive 35. And we're going to set what's inside equal to negative 35, and we're going to solve each equation separately. So for the left equation, we want to get rid of this minus 3 first, so we're going to add 3 to both sides of our equation. So we have 2b equals 38. And now we want to divide out this 2 on the left side, so we divide both sides of our equation by 2. On the left side, we are left with b, and on the right side, 38 divided by 2 is going to give us 19. So for one of our answers, we get that b is equal to 19. We're going to do a similar thing for the right equation. So we're going to start by getting rid of the minus 3 by adding 3 to both sides of our equation. On the left, we are left with a 2b. And on the right, negative 35 plus 3 is going to be negative 32. Divide both sides of our equation by 2 to get rid of the 2 on the left side. So we're left with a b on the left, and negative 32 divided by 2 is negative 16. So we get that b is equal to 19, or negative 16. So for our final example, we have negative 5 times the absolute value of 6y minus 12 plus 11 equals negative 24. So we need to isolate this absolute value. So we're going to start by getting rid of this positive 11, or this plus 11, by subtracting 11 from both sides. On the left side, we're going to be left with negative 5 times the absolute value of 6y minus 12. And the plus 11 and the negative 11 go to 0. So those go away. And on the right side, negative 24 minus 11 is going to give us a negative 35. And now remember, before we can evaluate whether or not we have no solutions, even though we have a negative on the right side, we have to get our absolute value by itself. So we have to get rid of this negative 5 on the left side of our equation. We're going to do that by dividing both sides by negative 5. On the left side, negative 5 divided by negative 5 is 1, so we're left with the absolute value of 6y minus 12. And on the right side, negative 35 divided by negative 5 becomes a positive 7. So now that our absolute value is isolated, and we have a positive number on the right side, we know that we are going to have two solutions. So we're going to break up our absolute value into two equations, set the inside equal to positive 7, and set the inside equal to negative 7. And I'm going to start by solving the left equation. So we're going to start by adding 12 to both sides. We're left with a 6y on the left, and 7 plus 12 is 19 on the right. Divide both sides by 6, and we get that y is equal to 19/6, which cannot be simplified, so we'll just leave it as an improper fraction. And then finally, let's solve this right equation. So again, we're going to start by adding 12 to both sides. We're left with a 6y on the left. Negative 7 plus 12 is going to give us a positive 5 on the right. Divide out this 6, so divide both sides by 6. We're left with 1y, or just y on the left. And on the right, we get 5/6, which also cannot be simplified. So we get that y is equal to 19/6, or y is equal to 5/6. So hopefully this video helped you guys learn how to solve absolute value equations. Always remember that you want to isolate the absolute value first, and then set what's inside the absolute value equal to the positive and negative value of the other side of the equation.